video, I want to look at translations of functions. So when we only have a formula, what's the result of the translation and what does it do? Now, just as a reminder, when we shift a function or a graph up, down, left, or right, we're performing what's called a translation or a shift. When we replace the inside of the function, in other words, we replace the x in f of x with something else, the translation's horizontal, left or right. When we add or subtract on the outside of f of x, the translation is vertical, so we go either up or down. The horizontal one always seems a little bit backwards. If you add a value, you move to the left. If you subtract a value, you move to the right. Whereas vertical is more straightforward. Add a value, you go up. Subtract a value, you go down. We're going to look at the function f of x equals x squared minus 3x minus 4. And we're going to do some translations to it and then write a formula for that translation and describe it in words. We'll start with f of x, and then on the outside of f of x, minus 10. What will that look like as a formula? Well, I'll take f of x, which is x squared minus 3x minus 4. The whole thing is f of x. And I will subtract 10 from that. Simplifying, that gives me x squared minus 3x minus 14. In words, the effect would be to move f of x down 10 units because that minus 10 was on the outside. Let's try another one. F of, and then in parentheses, x plus 4. Now we've replaced x with something else. So when we replace the inside of the function with something else, we have a horizontal translation. And since we're adding 4 on the inside, we would be moving f of x to the left 4 units. And how would I write this? I'll start by making a skeleton for that original function. It's something squared minus 3 times something minus 4. Now we just put x plus 4 inside those sets of parentheses, which gives us a set of parentheses holding x plus 4, which is squared, minus 3 times a set of parentheses holding x plus 4, and then minus 4 on the outside. Let's just leave it like that. That is a formula for the translation. We're not going to worry about simplifying it. Now we're going to do this backwards. So if I wanted to move f of x to the right 2 units, I would need to move it horizontally, which means it's got to be a replacement, an inside move. And instead of f of x, I would want to have f of x minus 2. That would move the graph to the right 2 units. What would that formula look like? It would be in parentheses, x minus 2, and then outside the parentheses we'll square it, minus 3 times a set of parentheses holding x minus 2, and then minus 4. Very similar to the one above. And then finally, if we want to move f of x up 5 units, we need to do something to the outside of the function. This is going to be vertical, which is how I know it's on the outside. So that would be f of x, and then on the outside of that, plus 5. In this case, that's going to be x squared minus 3x minus 4. That's the original f of x function. And now I'm going to add 5 to that. Simplifying, that would be x squared minus 3x plus 1. That one's not so bad to simplify. So let's try something that's a little bit more difficult now. The graph of g of x equals 1.5 times the square root of x plus 0.25 needs to be translated so that the endpoint is at 0, 3. So our goal is to put the endpoint at 0, 3. I'm going to put that in the lighter blue color. The question is, right now, what does this graph look like? So let's take a look at it over in Desmos. Over in Desmos, we can see that this graph is a square root graph. It has an endpoint at negative 0.25, 0, and a y-intercept of 0, 0.75. We probably have some other nice values, maybe at 7, 4.039, so about 7, 4. Now, we currently have an endpoint at negative 0.25, 0. We need to move it to 0, 3. Let me go back to my notebook and just draw this. So what are we going to have to do from this point that we started with, this point of negative 0.25, 0? Well, we need to move 0.25 to the right, and then we need to move from that point 3 units up. We need to go from 0 up to 3 for the y value. So we need to go 0.25 to the right and 3 units up. Well, we should be able to do both of those things, right? We've got to do g of, let's see, instead of x, we've got to do replacement to get to the right. So we do x minus 0.25. And then to go up, we need to do something to the outside. So on the outside of that, we'd have plus 3. So the yellow part, the replacement of x with x minus 0.25 gives us 0.25 to the right. And the plus 3 is what's going to give us 3 units up. We just need to calculate what that is. Now, one of the nice things is that you can actually tell if you're right, because in Desmos, you could simply say g of x minus 0.25. You can see the graph just shifted to the right by 0.25. And you could add plus 3 to the outside of that, and you'll see it moves up 3 units, and it has an endpoint of 0,3, which is perfect. So we know we've chosen the right translation. We now just have to find the formula. So let's go ahead and plug that in. We're going to plug in the x minus 0.25 for the x. So that will be 1.5. So I'm writing down g of x with the replacement. 1.5 times the square root of x minus 0.25, and then there's a plus 0.25 that was already inside that, and then I want to add 3 to the outside because that came from the formula, and that gives us 1.5 times the square root of just x, because minus 0.25 plus 0.25 goes away, and on the outside I have plus 3. To double check that, I can go back to Desmos and make sure that y equals 1.5 square root of x on the outside plus 3 gives me the exact same graph. And it does, so I know I've done it correctly. All right, now one for you. We have this p of x graph we've seen before. It's p of x equals negative 0.25 times, in parentheses, x minus 20. That whole thing is squared. And then plus 30 on the outside. This represents the profit in thousands from making and selling x sculptures. We want to shift this profit function so the maximum profit actually occurs at 15, 40, and then write a new formula for that profit function, p sub 2 of x. The current profit function has a vertex at 20, 30, with x-intercepts at about 32, 0, and about 8, 0. Those are ish, right? So I'm not positive that's what they are, but they look like that. It's a parabola that opens down. Give this one a try and see if you can't write a function that has the proper translation. Okay, we're back. We want to make the vertex 20, 30 happen at 15, 40 instead. So I'm going to graph that. And what I can see is that to get there, I need to move up 10 units and then to the left 5 units. So let's just write that down. Up 10, left 5. An up 10 is plus 10 on the outside, and a left 5 is an x plus 5 on the inside. So we actually need to find p sub 2 of x, which is going to be p of x plus 5, and then close that parentheses, plus 10 on the outside. That should give us the up and left that we're looking for. So let's go ahead and find that. Starting with p of x, we're going to replace the x with x plus 5. There's only one x in p of x, but it's inside a parentheses, so it's a little tricky. So we're going to start to rewrite p of x. That's minus 0.25 times parentheses. Instead of x, we're going to write x plus 5. Just going to highlight that so you can see it. And then we have a minus 20. Close the parentheses, squared, plus 30. That all together would be p of x plus 5. And then we do need to add 10 to the end of that. Okay, so simplifying, we have p sub 2 of x equals negative 0.25 times x minus 15, the quantity squared, plus 40. And that should give us what we need to shift this parabola, 10 up and 5 to the left. I'll leave it to you to check that with Desmos. Now let's just think a little bit deeper about what we've done. Let's say we start with f of x equals x squared. Without graphing it, how has g of x equals, in parentheses, x plus 1, that quantity squared, plus 5 to the right, how has that been altered from f of x? Well, the x plus 1 inside the square tells us it went 1 unit left, and the 5 outside the square tells us it went 5 units up. If you went and found f of x plus 1 in parentheses and then plus 5 on the outside, you would actually get g of x. What's the vertex of this function? Well, do you guys remember vertex form? That would be something like g of x equals a times x minus h, the quantity squared, plus k. And this is in vertex form. The a value is 1. X minus h would be x minus negative 1, so the vertex would start with negative 1. And then the k would be 5, that plus 5. Now the original vertex of x squared would have been 0, 0. So what we've done is we've moved the vertex 1 unit left and up 5. And that is exactly what we get in the vertex formula. And that, in fact, is one of the reasonings for why the vertex formula is what it is. If we started with f of x equals ax squared, how has g of x equals a times, in parentheses, x minus h, the quantity squared, plus k, how has that been altered from f of x? Well, it would have moved h units to the right and up k, placing the new vertex at h comma k. So let's just do one more thinking experiment here. Let's suppose we start with f of t equals the square root of t. This would be a square root function with an endpoint at 0, 0 going up. Without graphing, how has g of t equals the square root of t minus 4.5 under the square root plus 3.2 on the outside? How has that been altered from f of t? Well, what we've done is we've taken f of t, and instead of t, we replaced it with t minus 4.5. That changed the inside of the function. And on the outside of the function, we added 3.2, which means that we went right 4.5 and up 3.2. So if the original endpoint was at 0, 0, and we go right 4.5 and up 3.2, our new endpoint should be at 4.5, comma 3.2. So if you always thought that there was kind of an odd coincidence between, the numbers that made up square root functions and their endpoints, there is some coincidence between that. Essentially, we're just shifting the square root function up, down, left, and right